Good morning. Yesterday we talked about insertion into an AVL tree. And today we will take some examples, and we saw that we had to use different types of rotations to preserve AVL property. Today I'm going to talk about deletion, and deletion, this is more complicated than insertion. And let's see how we'll do this. Before that, yesterday we had left some 2 months which were not completed. So let's say we complete insertion of October and September. Also into the tree, all the 12 months will be there, and we'll have gotten this tree after rebalancing. And now if we compute the balance factor, -1, 0, -1, 0, -1, -1, 0. Okay, so it's a nice balanced AVL tree. Now let us attempt deletion. Suppose we delete February, the node February from the tree. Then what happens? This node is going to get removed. So then what happens here? This is fine, this is fine. This is going to become +2, right? And this will still remain -1. So what happens is we need to get this corrected. So what do? We perform a we perform a left rotation, and when we perform a left rotation, what we get is a tree like this. Yet April, December, March, July, June, and November, May, October, and September. Now the 0 minus 1, this minus 1 is also minus 1, but this is going to become minus 2. This also is a serious problem here. So now we need to rotate again, and this leads to this part. You know, this minus 2, this is 0, 0, 0, 0. But this becomes minus 2. So another complicated rotation is required. And so what do we do now? So we move. So basically you need to reduce the height. So reduce the height on this tree, that means this has to be moved. This is a kind of a left-right rotation. And what we'll do is we'll characterize them somewhat differently, okay, after a little while. But this is what it is. And we move left, right, that's what we have to do. So we move March to the root. And then Jan becomes the left child, whose left child is August, and whose left and right children are April and December. Okay, this was as before. Now, since March has become the root and its left child is Jan, this July and June have to become the right children of Jan. Okay, because they are clearly, these are greater than Jan but smaller than March. So we get this, and then we get November here connected to May, September, October, and September. So this is your final balanced tree. 0, 0, 0, 0, 0, minus 1, 0, 0, 0, minus 1, minus 1. Okay. So deletion. But you know, all that you need to realize is in deletion, the in insertion, what we did was the rotations are performed along the path from inserted node to root. Okay. Whereas in deletion, the rotation starts from again again it's the nearest ancestor whose balance is violated. Okay. That's where and here also starts from the nearest ancestor whose balance is violated. But the nodes that participate, nodes are not, need not be nodes need not be on the path. Okay, from deleted node. Okay, because it has to happen on the other nodes on the other tree participate. Okay, what I'm going to do is let us kind of generalize this for. So let's do the generalization, and we'll see what the differences are between insertion and deletion. Okay. So let us look at insertion, and so clearly whatever it is, it's based on whether insertion or deletion. It is based on balance factors of a particular node. Okay, so let's see how we go about this. Oops. So in insertion, we see this. A node A is, let's say, connected to a node B, which has left and right children. Okay, left and right subtrees. And similarly, the node A also has a right subtree. Now, let's say the balance factor at this node is 1. Balance factor at node B is 0. This one has a height of h, this has a height of h, this also has a height of h. Now, let's say during insertion, we insert in this part. Okay. And what is happening is 0 here, not 0 anymore. I add a node here, becomes BL prime, and let's say its height becomes L plus 1. This one is B, R still, whose height is still H, and then you have AR, whose height is H. Okay, I'm going to show for one direction. Okay, you perform a left rotation now because the balance factor at A is violated. Now what do? We move, rotate it, left. So what happens here? B becomes the root, BL prime of H plus 1 is one subtree, and since B becomes the root, its right subtree becomes the left subtree of A. Okay, and it still has the right subtree of H. Now, this becomes 0, and this one is also 0. Okay, this is your new balanced tree. Now, when do we perform a left-right rotation? Okay, again, the same scenario. If we have 1, this is A, this is B, B has a balance factor of 0, BL, BR, H, H, and this is, let's say, right subtree, again H, but now the insertion is happening here. Insertion happens over here in this tree. Okay, so let's see how this is in this subtree. And let us see again, after the insertion, I have A here, whose balance factor is violated. B becomes -1. And because it was originally height h, now let's say insertion happens here and the balance factor gets violated. So have some C over here, and whose balance factor is B, let us leave it, CL, comma CL. And this is AR, again of height h. So that means what? This was originally h and it's becoming -1 over here. Now what do? Now we do a left-right rotation, and this is LR. We've already categorized this, and you can do the same thing for the other side, right and the right left. So, and then now what we'll do, we'll make C the root here, and B will become, sorry, this will be C, balance factor 0. This will be B, you can have BL and CL. This should also have a balance factor of -1, therefore it becomes 0 here. And does that reduce the height of this tree? This is A, and this should have CR and AR. And now this is of height H, this is of height H, this was height H plus 1, so this will become height H 0. Okay, so this is what we do in insertion. Now let us look at, so this is the generalization. Now I did left and left-right rotations. Okay. Now let us look at the deletion. We have a similar generalization, but the generalization is somewhat different from what we have seen. So just as we did characterized insertion, if the, let's say we have a node Q, or we have a, let there be a node Q. If the deletion took place from the left subtree of Q, df of Q, and df of Q decreased by 1, if the deletion took place from the right subtree of Q and df of Q increased by 1. then we have the following observations. The following properties hold, and depending upon this, we have to see what we need to do. So if the new balance factor Q equals 0, its height has decreased by 1, and we need to change, it is already taller, change the BFs of parents and ancestors. Okay. If the new BF of Q is either -1 or +1, its height is the same as before. And nothing needs to be changed. If the new balance factor Q is -2 or +2, there is an imbalance. Okay. So, and balance factors propagate to the root with appropriate rotations. Okay. So let's look. So we characterize the imbalance. Type left if the deletion took place on the left subtree, otherwise it is characterized at right. Now what you will see is similar to insertion. We look at the node whose balance factor becomes 2. So let's go back to this tree that we had. A and B and L, B, R and AR. Okay. So this is the tree that we had earlier. And let's say this pair of height H, height H, height H, and this was 1, and this becomes 0. Now, what it's going to depend upon is this, let's say this is I'm taking one type of rotation, okay? Let's look at the right rotations. Okay. So obviously this is a node, let's say, whose balance factor gets violated. It happens, the rotations are based on the balance factor of B, the node B. Okay. So what did we talk about? So what happens is this becomes 2, let us say, because there's been a deletion on B. And let's say this is 2. So BF of B can be 0, 1, or -1. Okay, that's what we need to look at. It depends upon what the balance factor of this guy is. Suppose this becomes, A becomes 2, because there was a deletion on, sorry, yeah. So what is happening here? Sorry, let's say the balance factor gets disturbed at B. A. The balance factor of B is 0, in this, and B are. These are of both height, H, H. If this has become 2, clearly there must have been a deletion over here. And this has height of H minus 1. Okay, so I'm taking the right subtree deletion now. Then balance factor of B is 0. Then we perform what is called an R0 rotation, and B is moved to the root. So B becomes here, get a -1 here, and this is left H, A, and so this will reduce it, and this will become 1. We'll have BR H, AR prime of H minus 1. Now, suppose we had the same thing here, but now, let's say this is A, its balance factor is 1, B, its balance factor is 1, BL, BR, this is H, and so this has to be H minus 1, because this fellow's balance factor is 1. B. Okay, and let's say I have AR of H over here. Now again, deletion happens on the right subtree of A. Then this becomes 2, and will be H, BR, H minus 1, because balance factor is 1 here. I have AR prime here, which is H minus 1. Now again, what do we do? This B again becomes the root. Similar, BL, 8 becomes the child of root, and we have BR of H minus 1 here, AR prime of H minus 1. So it's kind of similar what we did over here. It's just that A has a balance factor of 1 there. Here it has a balance factor of 0. Okay. Now, finally, let's say we started off with A and B was -1. If it was -1, what is the situation? We have BL here, H minus 1, and there is some node with some balance factor. Let's call this node C. CL, and this is a complicated rotation. And this is AR. Now again, height H, and this has a height of, so this is -1 means what? This is a height of H. Okay. So now what we're going to do is, let's say it becomes 2 because there's again a deletion on AR. -1 and BL H minus D CL CR, and this becomes AR prime of H minus 1. Height is reduced. You only have to worry when the balance factor becomes imbalance is what we're looking at. So now this node C will go here. So this is like a right-left rotation, which we are talking about. So what happens now? The new tree that we will have, this is C, this is B, and we have BL, H minus 1, and CL, which is also should be H minus 1, and we have right child is A, sorry, and the right child is A, and then we have CR and AR prime, which are both H minus 1. Okay. All right. So this is how we work this out, and so we're looking at the first node whose balance has been violated. I think correcting what I've done now. -1. Okay, this one's height reduces, this one's height reduces, and you get a new tree. Okay, so this is called an R minus 1 rotation. Okay, so what does it mean here? You look at basically, given the node whose balance factor is violated, on the other subtree, you look at the child, and you look at the child that is there, and look at the balance factor of the child. And that will tell you what kind of rotation has to be performed. Okay. So we